Okay, so I'm here to talk to you about how you can improve concurrency and achieve a simpler, more modular architecture through actors. And in particular, I'm going to be talking about one type of actor. It's been around for decades. It's been thought of as a nice idea, but not really to be taken seriously, not really for anything meaty or high budget. And yeah, for a while there was a bit of a failure to launch. But in the past few years, we've seen a huge upsurge in the number of cores a server has. Almost everything is in the cloud. We've had something of a renaissance, and actors are back in force. So what I'm, of course, talking about is actor-based systems. Now, the actor model is an idea that was originated in 1973 in a paper by Hewitt, Bishop, and Steiger. The idea is that you design your system as a bunch of self-contained actors whose only interaction is through immutable messages passed between them. This is very much a peer-to-peer interaction. Any actor can send a message to any other actor, although certain actors may be only concerned with processing certain types of messages. So, actors versus microsystems. Microsystems are standalone components that serve a single purpose, and they may themselves be multi-threaded, whereas actors are isolated single-threaded components that encapsulate both state and behaviour. And they can be used to implement microservice environments, and we'll see soon how this can be done. So, why use actors? Well, in concurrent systems, managing state is hard. Managing mutable state can lead to race conditions, it can lead to visibility issues, it can lead to a lack of atomicity. Now, in an actor system, all internal state is maintained by the actors. So, state held by an actor can be thought to be immutable and atomic. So, if you want to create, read, update, or delete state maintained by an actor, you send an immutable message to that actor, and it might send an immutable message back with the outcome of the operation and maybe the state that you wanted to see. One toolkit for implementing an actor-based system is called Akka, which I'll be talking a lot about. In Akka, there's a happens before contract. You can think of it as only one message being processed at a time. So if a single message asks an actor to change the state of A and B, then you're guaranteed that another message will only be processed either before both A and B have changed or after both A and B have changed. So Akka is a toolkit written in Scala. It's built on the JVM. There's user documentation available for Scala or Java users, and recently there's a new implementation for .NET users too. Now, adding Akka to your application is very simple. Any class you make into an actor must implement the untyped actor class and contain a method onReceive for handling those messages. Each message is a POJO, a plain old Java object. And in our actor's onReceive method, we have a very boring if statement here. And that if statement checks what type of message it is, it handles it, and then maybe sends a message back or sends a message on to another actor. Now, in our main class, we instantiate the Akka system and instantiate each of our Akka actors. And in a second, we're going to be instantiating them with a router, which we've configured in a configuration file here. So this is a fairly standard routing configuration. There's a router that has a fixed number of threads, and that number of threads can also be variable if you want to fine-tune how you handle load. You can also configure the router to drop messages if they reach a threshold, which can be very handy. And in our Java code, we initialize the actor with the router we configured. And there you have it. Just a few lines to turn our small Java class into an Akka-based system. Okay, so fault tolerance. So in any actor-based system, we have to build resiliency into that system. We have to assume that at any time, messages may not reach their destination, and we can't make assumptions about the type of messages we receive. So Akka allows us to delegate error handling to a supervisor actor, so error handling is a default. Okay, just moving on to distributed systems. We all know the reasons to build a distributed system over a monolith. It's more scalable, it's easier to release small components separately, and if you have single tenancy, it's easier to trace a fault to a single component, and it's easier to change resources in a bottleneck component. So, given that, Have you ever had the situation where you're building an amazing distributed system, the architecture is modular and perfect, and just for the moment, just for the MVP, you have the one small minimum program, you're going to put it in the one JVM, ready to split them out as soon as you add a little bit more functionality. Then you turn your back for 2 weeks, and suddenly it's turned into a huge monolith. Okay, probably a lot of you have seen this happening. How can we prevent this happening? So, Akka has recently released remoting capabilities. You can start with a single JVM with components designed as actors, and then you can scale up by using Akka Remoting. Any number of actors can occupy their own server, and it's easy to configure. There's no major code changes needed. And you can also combine remoting with routing, the routing that we just saw. Okay, so just to demonstrate how simple it is to add Akka Remoting to your code, here's some code. You add the Maven dependency. You add some configuration to your application.conf file. You configure your application to be able to talk to your remote actors. And finally, you use routing to set up a remote actor in several locations. And there you have it. That's all the code you need to move from one JVM to several. Okay, so before you leap out of your chair to redesign your application as an Akka system, here's a warning note. Increase in concurrency can also increase complexity. So in Akka, error reporting can actually be quite vague. You can't rely on the stack trace to tell you everything. Debugging from one actor to another can be very cumbersome. And you still need to learn about concurrency in Java. One book that I like that's still relevant today is Java Concurrency in Practice. So I'd recommend you read it if you haven't already, but make sure to read it in the correct way. Okay, so what have we learned? The actor model can be used to manage state in a concurrent system. Akka is a great framework for easily implementing an actor-based system. And Akka can be easily scaled up to a distributed system. So, thank you very much.